A television panel does not need glass anymore. That single fact is about to break a business that has printed money for a century. Engineers in China built a screen that shows real depth without glasses, without headsets, and without any trick lens taped to your eyeballs. It already works in public. It is already backed by billions of dollars. And it points straight at the flat screen sitting in your living room right now. For over 60 years, engineers everywhere tried to build a screen that shows true depth without forcing people to wear anything on their face. Nobody cracked it because of one basic fact about human eyes. Your two eyes sit a few centimeters apart, and each eye sees the world from a slightly different angle. Your brain compares those two angles constantly to figure out how far away things are. In the early 2010s, companies like Samsung and Panasonic tried to fix this with 3D televisions that needed heavy plastic glasses. People hated them. The glasses were uncomfortable, they made the picture darker, and nobody wanted to wear eyewear to watch a game on a Sunday. Within a few years, almost every brand quietly dropped 3D TVs. Most engineers walked away believing glasses-free 3D was never going to work for regular families. Then a team based in Hefei, working with Beijing University of Posts and Telecommunications, took a different route. In February 2025, they published their results in the science journal Light, Science and Applications. Their screen uses something called a light field display. Picture a curtain covered in thousands of tiny bumps, and each bump acts like its own tiny lens. Behind that curtain sits a screen packed with millions of pixels arranged in a very specific pattern. Each lens only lets certain pixels show through from certain angles. Stand slightly to the left, and one set of pixels reaches your eye. Step to the right, and a different set of pixels reaches you instead. As far as your brain can tell, it actually is. Here is where it gets interesting. This is not one lonely paper sitting on a shelf. BOE Technology Group, the single largest supplier of display panels on Earth, has filed a growing stack of patents tied to this exact technology. TCL, through its SOT division in Shenzhen, has shown working prototypes at major electronics trade shows, and the company has said clearly these are built with mass production in mind. The city of Hefei has poured billions of yuan into becoming one of China's biggest hubs for advanced display manufacturing. Companies do not expand factory lines for an idea. They expand them when real customers are placing real orders. That single detail tells you this has already crossed the line from a science experiment into something with actual money behind it. It is already outside the lab, too. Large glasses-free 3D advertising screens have gone up on buildings in Chengdu and Shanghai. And people stop walking just to look up at animals that seem to leap off the flat billboard. Museums in China have started installing smaller versions of these screens to show 3D models of ancient artifacts and human anatomy. With no plastic glasses handed out at the door, none of this means your television dies next year. A completely separate breakthrough is also worth knowing about, because it shows this fight is not one-sided. Back in 2018, a team at Brigham Young University led by Daniel Smalley published research in the journal Nature showing something even stranger. They used lasers to trap a tiny particle of plant material in midair, then dragged that single glowing point through space millions of times per second, tracing out full shapes that hung in the room with no screen at all. It is real, it is American, and it proves the idea of a screen-free future is not something only one country is chasing. NVIDIA just handed a GaN Supplier Award to a Chinese company most people have never heard of. That company now builds the power chips inside NVIDIA's newest AI systems. It is the only China-based firm on NVIDIA's approved list for a brand new 800-volt power design. But silicon is not actually obsolete. What really happened is bigger and stranger than that headline. And by the end of this, you will know exactly what changed and why it matters for every AI chip built after this year. The company is called Invention. It makes a material called gallium nitride, or GaN for short. GaN is not new science. It has been studied for years. But Invention found a way to grow it cheaply, at massive scale, and that is what changed everything. Here is the real problem it solves. Every AI data center burns huge amounts of power just moving electricity around before it even reaches the chip. Invention has stated that in older 48-volt power systems, more than 45% of total power can be lost just managing heat. NVIDIA's answer is a new power design that runs at 800 volts instead of 48 volts, jumping the voltage that high drops the current needed by about 16 times. Less current means less heat. Electric cars made the same jump years ago, moving from 400-volt systems to 800-volt systems for the same reason. But there is a catch. Building switches that can safely handle 800 volts at extreme speed inside a tiny space is something silicon struggles to do well. Gallium nitride can do it. That gap is exactly where Innoscience built its business. The founder is Luo Weiwei. She is not a typical chip executive. She spent 15 years at NASA, working her way up to chief scientist on rocket fuel research at the Marshall Space Flight Center. She holds a PhD in applied mathematics from Massey University in New Zealand. Then she left NASA, moved back to China, and bet her whole career on a material the industry called too risky to touch. In 2015, she founded Innoscience in Zhuhai. Here is the part that made her company different from every other GaN startup. Most companies that work with gallium nitride grow it on small, expensive, specialty wafers. Innoscience figured out how to grow GaN directly on standard 8-inch silicon wafers, the same base material the entire chip industry already uses. That single choice let them build at a scale nobody else could match. In under 6 years, Innoscience became the first company on Earth to mass-produce 8-inch silicon-based GaN wafers. Cameras on public roads are now taking pictures inside your car, not your license plate, your seatbelt, your phone, your passengers. This is not a future plan. It is already running in California, Connecticut, Minnesota, Arkansas, Maryland, and across the United Kingdom right now, and one county in England used this exact system to prosecute 2,200 drivers in a single 4-week stretch. Here is where it started. On the 91 express lanes in California, the Riverside County Transportation Commission spent $5 million to install cameras in the center median. As you drive under them, they fire multiple photos straight through your windshield into the front and back seats. The goal was to catch carpool lane cheaters. About 400,000 cars use those lanes every day, and officials say more than 100,000 of them break the rules. Roughly 25,000 drivers a month were using the free lane with only 1 or 2 people in the car. The cameras count heads. If the system flags a car, a real person checks the photo before anything happens.